It's Roger, Mud Fossil University. Who doesn't love opals? They just cracked this open. Where do you see this? But really, this is what I want you to see. This is from a leg or an arm. That is the internal part where the bone was internally in here. Now, I don't know if this is actually on the bone, the hard part of the bone, and that's the marrow, or this all is gone and this is flesh and that is fascia. That I'm not sure of. However, this is some form of a membrane. I believe we're going to look at this in a second. We're going to go back to the beginning and look at it. And as I've been showing, these opals take on transition metals because they have some form of a cellular matrix that has these specific transition metals in them. And that is why this is this type of color. Now, let's take a look at it from the beginning. Okay, so they've cut down through the opal vein. Here it goes, and they're looking at it.
Cut down to the opal vein. You can see it flowing here. Expose it as much as possible. And it's already got a natural little split in it. So we're just going to give a little tap, and hopefully it'll separate.
Okay, you can see that they've cut it all into pieces so that they can see this colored seam, and now they're going to break it open.
And weave Sam's magic yet again. Let's see.
Let's give it a little tap.
A surprise for the world. It's got a nice sound. Go on. Hose.
Water. Okay. Nobody has seen this.
Nobody?
We're all going to be the first.
Oh.
That's deadly. Now, you can see that's blood up in there.
Look at that.
All right, that is a blood vessel up in there, and this is some form of fascia, and they take on these different colors because the fascia itself is literally striped. You don't see it when you see them in living tissue, but once they take on their stabilization transition metals, that's when they take on, just like this heart. I'll show you. Okay, anybody that understands how a heart works will understand that's a heart, and they will also understand that they don't look like that until they become opalized. And if you understand transition metals and the cellular nature of life, the fabric of life is cellular. It's a structural cellular matrix, and when it stabilizes, it takes on a certain transition metal that it wants to be partnered with. That's why this is that specific color. The blood is red. All these little colors in there are different transition metals that are floating through your blood. They're the carriers of everything in your blood that carry things around because they are transition metals and they can link with a single electron. I'm not going to go deep into that. This is from the Yoa region of Australia, which is the terrestrial opals. So they were up in the highlands, but it's still soaked with blood. Somehow that area just is like a gigantic scab, totally saturated with blood. Ayers Rock, Uluru is a heart. I've absolutely no question. Now, so here's what we got is these colors, these transition metals, stabilizing in these specific tissues because they require that specific transition metal. And all biology that is structural has this ability to form opals in certain conditions, which was where Australia was. That's what happens in a lung. You have all of this changing of colors because the transition metals are doing carboxylation. They're giving up carbon, different acids are turning into gases, and there's a lot of colors in transition metals. That's just what they are. You see that? That's an opal eye. You see that? That's the muscle that attaches to the eye. I don't know, this was in a certain area that it took on these transition metals to be stable. Now, in a different area, the chemistry might be different, and the eyeball may take on a different color because of the transition metals that were there that were available. Right? There's more to it than just they're all going to turn into yellow eyeballs and green surrounding them. And there's that muscle. These are the transporters in your body. These are the different blood metals, and they end up going into salt solution type things where they have all these extra electrons, or they want electrons. That's how they bond to the little stuff. They carry it somewhere else. A little pH change drops it off or picks it up. You need these. You need all of these in you, and bacteria create these using enzymes. This is in China, and it is there, and there are other places that are just like this. Now, I don't know if that's enhanced or not, but I'm going to tell you one thing. There are these colors changing, and these stripes like that, and these black spots are where the blood infuses and lets it out, and I'll show you living tissue. All right, this picture from Ed Reschke and Getty Images, and that is tissue that's living, and it's fascia, and these are all little stripes, and they will change into different colors just as seen in the opalized ones. I'm pretty sure that's from a gigantic eyeball. I don't have any details on that, but boy, it sure is stunning.